Okay, so in last few days I discussed, means I started discussing that module 5, that is network theorem, and still it is continuing. Um, and in the last day, so far I can remember, and also you can remember also that nodal analysis, I think that I have started, and I have related that reason uh, behind going for the nodal analysis over the general method of analysis, like using KCL, KVL, and that relationship equation of an element. So over the general method, why nodal analysis that is becoming advantageous to solve a circuit, that I discussed in the last class. And also I have started in the last class the procedure for doing nodal analysis, and that procedure that I discussed is the general procedure, that is for a very basic circuit, you know. And today I will go for extending that procedure. That means there are many things like dependent sources that can be connected in the circuit, and there can be some combinations of sources which are means voltage sources which are not um, means by using the same procedure you cannot solve the specific combinations of voltage sources in the circuit using nodal analysis. So all these I will go one by one, and accordingly I will be introducing you some new concepts which need to be implemented for nodal analysis. Okay, so in the last class I ended up with the circuit that I am drawing now. See, in the last class I used the circuit, and for this circuit I have computed, means I have shown you that how to use nodal analysis for computing the node voltages. So by the nodal analysis we what we do, we compute the node voltages. Okay, so actually the very important issue regarding that nodal analysis was what we did in nodal analysis. In nodal analysis or node voltage method, um, KCL is applied to all the non-reference nodes nodes and the current equations are derived in terms of of node voltages uh, by applying element equations mentally. Okay, so this one was the thing that we did in the last class. Means you can see for these nodes, this node 1 and this node 2, the node voltages are V1 and V2, and at these two nodes we applied KCL, and by that KCL you know that KCL gives you the current equation. Okay, KCL gives you the current equation. That means algebraic sum of all the currents coming to a node is equal to 0. So its KCL gives the current equation. But we derived that current equation, or we have written. Okay, better if I write written written the current equations that you have got from the KCL at the different non-reference nodes. So that current equation is written in terms of the node voltages, and you know that while we are trying to represent, suppose, this current using node voltage, that means this current is equal to V1 minus 0 by R1. So this way, by applying elemental equations or element equations for different elements present in the circuit, we represented that current equation in terms of the node voltages. So this was the basic that I discussed in the last class. Now there is another way. So this is the method. Now whatever equations that you have got, now that equation you can solve. Say you know that there can be Cramer's rule or a very general method of solving the algebraic equations, but there is another way. We can directly write down the equations in matrix form. Okay, already you have gone through the matrix algebra in mathematics, and you know that the linear equations or linear algebraic equations can be represented by some matrix forms. So do you agree with me that you have gone through all these concepts of matrix algebra? That means linear algebraic equations can be represented by in matrix form. So are you agree
Yes,
with me?
sir. Yes, sir.
Yes.
Yes,
So
sir.
okay, so already
Yes,
you
sir.
know that
Yes, sir.
how to express the linear algebraic equations by means in matrix form. So here also we will not go for applying that. Actually in background we will apply that KCL, KVL, everything. Okay, but we will not go for means node by node. We will not go for applying that KCL, KVL. Actually after KCL, KVL, whatever equations that I wrote in the last class, okay, so that equation if you rearrange and if you write in terms of the uh, means okay, let me write it down directly over here. Or so V1 at node 1, KCL at node 1. So KCL at node 1, it will be this V1 by R1 plus V1 minus V2 by R2 equal to I1. Okay, so this one if I write, then it will be like in if I rearrange all these things, then it will be 1 by R1 plus 1 by R2, then V1 minus 1 by R2 V2 is equal to I1. Okay. Okay, sorry, there is another term, that is minus I1 here, sorry, minus I2. here it will be also present minus I2. Okay, so this will be minus I2 or this one. Okay, so here I have rearranged the equation, and then again if I apply KCL at node 2, then at node 2 it will be V2 by R3 plus V2 minus V1 by R2 equal to I2. Okay, so here I can rearrange again, that will be minus 1 by R2 V1 plus 1 by R2 plus 1 by R3 V2, that is equal to I2. Okay, so this is the these are actually the two equations. If I rearrange the equation, these are the two equations actually coming. Okay, so these two equations, if I write in terms of it means in matrix form, then it can be written as, in matrix form, it can be written as like 1 by R1 plus 1 by R2 here, minus 1 by R2, and here it is minus 1 by R2, here it is 1 by R2 plus 1 by R3. Okay, so this will be like this, and again it will be like V1 V2 over here equal to, over here it is I1 minus I2 divided by I2, sorry, and I2. So this way we can write the two equations, these two equations 1 and 2, these two equations we can write in matrix form like this. So I think all of you are agree with me. Any confusion or anything that you please tell me, that any confusion if you have. Okay, immediately you interrupt and you please tell me that what confusion you are getting. So I think all of you are agree with me right now, till now.
सर नोट 2 में केसीएल के अप्लाई को जरा बता दीजिए.
नोड 2 में केसीएल जो अप्लाई किया नोड 2 में, इसी नोड में ना?
यस सर.
अच्छा अच्छा, देखो इस नोड में जब नोड 2 में केसीएल अप्लाई कर रहे हैं, तो बात यह है कि हम कंसीडर कर रहे हैं कि ये करंट है, ये तुम्हारा करंट है. ओके, सो दैट इज बाई V2 माइनस V1 बाई R2 प्लस V2 माइनस 0 बाई R3 इक्वल टू I2, और V2 माइनस V1 बाई R2 प्लस V2 माइनस 0 बाई R3 माइनस I2 इक्वल टू 0.
ओके सर.
ठीक है. ओके.
यस सर.
Okay, so this equation that we have got, you can see right now. Okay, now you see one thing. So all this 1 by R1, 1 by R2. So what is this actually 1 by R? Can anyone say this 1 by R is what? Means is there any particular term that you know, that 1 by resistance?
Yes sir, conductance.
Yes.
Conductance.
Good.
Conductance.
That is conductance. And you know that means by which letter this conductance is represented?
Rho sir. Rho.
No.
P1 sigma.
सर म्यू.
No.
Sir, 1 by rho.
That is G over here. Okay, so you see, whatever rho you have said, it is okay. Okay, that is called resistivity. R equal to, that is related in this manner, rho R equal to rho into L by A. Okay, so whatever row you have said, that is what resistivity. Okay.
Yes, sir.
Yes, sir.
Okay, so that is there also. Okay, but conductance is in electrical, that is represented by G. Okay, so now you see that in a very general form we can write it as, here you see 1 by R1 we can represent it by G1. Okay, so this way I am representing. So here so what is the analogy that we can draw over here, that you just see. Okay, okay, so now you see what analogy. See, already these two means this matic formation we have done by using this 1 and 2. Now we will go for the analogy that we will, means what is the analogy that we are getting from the circuit diagram directly, that we will see right now. Okay, so what we can see over here is this term over here is, in terms of conductance, it is G1 plus G2. Okay, now you see here it is V1, here it is V2. So these are the node voltages. Okay, now you see that you know, if you do the matrix multiplication, then it will be like this portion will be multiplied with this and plus this portion will be multiplied by this. Okay, and these two will be added up. Now you see this one is coming what, minus G2. Now you see over here, this portion is called whatever resistances or whatever resistances are connected directly with the node, that summation of the conductances of that will be the element present in this portion. Okay, so this is the G11 portion. That means at this node how many means what are the conductances are connected, this is G2 and this is G1. Okay, so only two conductances are connected, so sum it up and put it over here. Okay, and this one, this portion you see, that is G12. That means what is the mutual between node 1 and node 2, that conductance you have to put over here. Okay, so that is why you see that is minus G2, and whatever mutual conductance is there, that will be written by putting minus sign. Okay, so similarly if you go for, okay, so have you understood this one, this line if you understood, then I think in the similar means using similar logic you can build up this second line. Okay, so you just means try to memorize all these concept, means this concept right now that I have said, and try to put the values in this second line.
Sir, minus G2.
Minus G2, because why? Because
Sir, 1 by R2 is equals to G2.
yes, this portion is your called as G21. Okay, node between node 2 and 1, what is the mutual conductance, that you have to put over here with minus sign. Okay, okay, and this portion it will be
Sir, G2
G1
plus G3.
plus G2.
G2 plus G3.
G2 plus G3.
G2 plus G3.
Yes,
G22 part.
yes, G2 plus G3. So this is the part which is G22.
G22.
Okay, that means whatever impedance means conductances are connected with this two terminal directly connected, that will be added up. Okay, so R2 and R3 they are connected, so that will be G2 and G3. And on the right hand side there will be the sources present. You see at this source, means at this point at node 1 the sources are connected like I1 going into I2 going out, so it will be like I1 minus I2. Okay, and over here whatever is the source connected, current source, that will be you have to put over here. So that is true for the current source present in the circuit. Okay, so
I
that
to
is true.
sir.
So this way, without forming, means without applying KCL to all the nodes, directly you can write it down. Okay, and for writing it down, whatever I have said, that observation you have to go through while writing that equation in matrix form. Okay, so directly you can write also. Understood? So
Yes, sir.
so this is
Yes.
another way of writing the equations. Okay, nothing else. Or if you
Sir, what is the meaning of
yes.
G11, G12, G21?
See, these G11, these are called self
Sir, could you
conductance
please
and mutual
elaborate that?
conductance. So G11 and G, these are called self conductance. G22, these are called self conductance, because you see that these conductances are directly connected to the particular node. This is self conductance for node, this is self conductance for node 1, and this is self conductance for node 2, and G12 or G21, these are the mutual conductances. Okay, understood? These are putting mutually, means these are connected mutually between these two. Okay, so so this is all about that. I am just telling you about the general procedure of applying nodal analysis to a particular circuit. Okay. So now I am going for a new thing. Okay. So now I am going for applying nodal analysis when there is independent source present in the circuit. Okay. So nodal analysis with independent, independent sources was there already, with dependent source in the circuit,
Sir,
Yes.
what is self-conductance and mutual conductance?
See, this self and mutual conductance, actually this is what can I say, this is a term that we are using over here. Okay, for now this is a term that we are using over here. We are just specifying certain number of conductance, means certain conductances which are mutual for both of these nodes. Okay, and some conductances we are taking just separate, which are connected to a particular node. Okay, so it may be mutual or it may be with respect to any point. Okay, means whatever conductances are connected directly with a node, that we are just segregating, we are just giving a separate name. This is called self conductance, and whichever is the mutual.
Sir,
Yes, please.
sir, then this is just a name as we read in self-inductance and mutual inductance, like that, sir.
Yes, this is just for distinguishing this set of conductances. Okay, nothing else. And by that also, there you can see that mutual conductances are the conductances which are mutual between the nodes, and means between two particular node, and